It began with a whisper from the edge of time. A sliver of light, stretched thin across billions of years, flickered into the James Webb Space Telescope's field of view. What it revealed would not just rewrite the record books, it would ignite a deeper mystery about the universe itself, a mystery that scientists are still struggling to comprehend. For years, Hubble reigned supreme. Its powerful 2.4-meter mirror gave us astonishing images of the cosmos and helped us peer deep into the past. One of its crowning achievements was discovering GNZ 11, the most distant galaxy ever found at the time, a delicate wisp of starlight from a time when the universe was less than 500 million years old. That moment felt like standing at the shoreline of cosmic history, staring into the sea of creation itself. But the James Webb Space Telescope, it didn't just walk further down that beach, it plunged into the ocean. With a 6.5-meter mirror and infrared eyes designed to capture the stretched-out light from the universe's earliest moments, Webb was humanity's most ambitious attempt yet to glimpse our own origins. And then it found something astonishing. A galaxy, faint but unmistakable, now known as JADE's GS Z14.32. That number, so abstract to most of us, meant one extraordinary thing. This light had left its galaxies just 290 million years after the Big Bang. It was, quite literally, older than our imaginations were prepared for. And then, before astronomers could even catch their breath, another whisper came through the cosmic static, a signal just slightly more distant. It was given a name that didn't quite reflect the magnitude of its importance, MAM Z14. This galaxy had a redshift of 14.44. That meant it formed even closer to the beginning of time than JD's GS Z14-0. But the number wasn't the most shocking thing. It was what this galaxy looked like. MAM Z14 wasn't a swirling, majestic spiral like the Milky Way. It was tiny, just 500 light-years across, compared to the Milky Way's massive 100,000. In galactic terms, it was barely a smudge, but what stunned researchers was how brightly it blazed. It wasn't supposed to be like this. At that point in cosmic history, galaxies were thought to be dim, chaotic collections of gas, barely forming stars. But MAM Z14 was a furnace, its core erupting with a frenzy of new stars being born, one after another, in a cosmic firestorm. It was like finding a lighthouse in the middle of a fog-covered sea. A beacon, not just of light, but of possibility. But there was something missing, something troubling. There was no sign, none, of a supermassive black hole at its center. This is a big deal. Modern astrophysics tells us that most galaxies, especially the bright, busy, star-forming ones, have a gigantic black hole at their heart. It's not just coincidence. These black holes, millions or even billions of times more massive than the Sun, are thought to play a central role in regulating galaxy growth, balancing star formation, and shaping the very structure of the galaxies around them. But MAM's E14 defies that. It's doing all the things galaxies with black holes do, without the black hole, and that wasn't even the biggest shock. When scientists trained Webb's sensitive instruments on MAM Z14, analyzing the specific wavelengths of light it emitted, they expected to find simple elements, mostly hydrogen and helium, the basic ingredients of the early universe. But what came back changed everything. There was nitrogen, a surprising amount of it. Nitrogen isn't a basic element in cosmic terms. It doesn't form in the earliest seconds of the universe. It's the byproduct of life cycles, massive stars forming, aging, dying in violent supernovae, and seeding their surroundings with heavier elements. The presence of nitrogen meant only one thing. There had already been multiple generations of stars before MAM Z14 even came into existence. It was like opening the first chapter of a book and finding notes scribbled in the margins from earlier versions no one knew existed. MAMS 14 wasn't the beginning. It was a continuation, a clue that the universe had been forming stars and recycling them far earlier than anyone thought possible. And that opened a door. If a galaxy this complex could exist so early, how many more were out there? Before Webb, galaxies like this were thought to be incredibly rare, but now they're being found more often. These ancient glowing little red dots, as they've come to be called, are showing up in deep field surveys at a surprising rate. One after another, these bright, compact, chemically rich galaxies are calling into question everything we thought we knew about the early universe. MAMS 14 may be the most extreme case yet, but scientists believe it won't hold the title of most distant galaxy for long. Webb is just getting started, and each discovery sends ripples through the foundations of our understanding. The standard model of cosmology, our best theory for how the universe formed and evolved, rests on the idea that the early cosmos was a slow, steady process. Galaxies grew gradually. Stars formed in waves. Chemical complexity came later. But what if that's wrong? What if the early universe was a place of chaos and speed and complexity? What if galaxies sprang up like wildfires, fast and bright, evolving not over billions of years, but in just a few 100 million? That's what MAMZ 14 is whispering from across time, a tiny galaxy with a loud voice. And as astronomers dig deeper into Webb's treasure trove of data, they're finding more questions than answers. Each new galaxy is like a puzzle piece that doesn't quite fit, a riddle in a language we're only beginning to understand. MAMZ 14 doesn't just raise questions, it challenges assumptions. It shakes the pillars of our models. It hints that the universe may be older in some ways, faster in others, and far more mysterious than we dared to imagine. What the James Webb Space Telescope is revealing isn't just distance, it's a different kind of time, a deeper, more chaotic past, filled with surprises that seem to challenge everything our best minds thought they had figured out. And MAMS 14 is the flare at the heart of that disturbance, burning impossibly bright from the young darkness of the cosmos. The questions are growing louder. Why is this galaxy, so small, so early, so far away, bursting with nitrogen, that unmistakable fingerprint of recycled stardust? How could there have already been multiple generations of stars, forming, exploding, and enriching the gas clouds with heavier elements in a universe that was barely a few 100 million years old? To understand how strange that is, imagine rewinding history to the very first few pages of the cosmic story, where the ink is still drying, the sentences barely formed, and finding entire chapters already written. That's what this galaxy is, a contradiction. A relic of complexity in a time we believed should have been simple. And that contradiction is unsettling. MAMS 14 suggests that the cosmos may have been sprinting, not crawling, through its early growth stages. That it might not be the exception, but the rule. It's like discovering a mature oak tree on a volcanic island that supposedly only erupted a week ago. Something doesn't fit, and that dissonance is pushing astronomers to rethink the very foundation of their models. Worse, or maybe more thrilling, is the realization that MAMS 14 may not be alone. The Webb telescope is spotting more and more of these little red dots, compact, bright galaxies where there should only be dim, dusty whispers. With every new observation, the supposed rarity of such galaxies seems to erode piece by piece. They are not the scattered oddities we once assumed. They're everywhere. They are singing an ancient song in a chorus we had never heard until now. Each one lights up the sky with its own strange tune. And each one deepens the mystery, because with each newly discovered ancient galaxy comes another violation of our expectations. Brightness where there should be shadows, complexity where there should be simplicity, organization in chaos. And, perhaps most surprising of all, a distinct absence of the black holes we've come to expect at the center of such intense activity. For decades, astrophysicists have built a framework around the idea that supermassive black holes serve as gravitational architects, helping galaxies grow, regulating star formation, even shaping the flow of gas and matter. But MAM-ZE 14 and its growing family seem to defy that logic. They don't play by the rules. If these galaxies truly evolved without black holes, or without the ones we can detect, then the entire narrative of galaxy formation may need a rewrite. We may be standing at the edge of a paradigm shift, where the rules of the early universe were more violent, more accelerated, and far stranger than anything we've modeled. And then, as if that weren't enough, a second mystery began to surface. When astronomers began analyzing how galaxies spin, they noticed something eerie, an unusual preference for a single direction of rotation. It might sound small, but in a universe that should be random on the largest scales, it was like hearing all the clocks in a city ticking in rhythm. Galaxies, like giant pinwheels, can spiral either clockwise or counterclockwise, depending on how you look at them. In a perfectly isotropic universe, there should be an even distribution, half one way, half the other. But that's not what we're seeing. There's a slight, yet statistically significant bias, a strange alignment that shouldn't be there. It was as if the universe itself was favoring a spin, nudging galaxies in a particular direction. And that raised a possibility so bold, so staggering, that some scientists could barely bring themselves to say it out loud. What if our entire universe exists inside a black hole? At first, it sounds like science fiction, but the more you look at it, the more the idea begins to hum with a kind of terrifying elegance. The theory, sometimes called Schwarzschild cosmology, suggests that the Big Bang wasn't an explosion from nothing, but a bounce, the expansion from within a black hole that formed in a larger parent universe. Instead of infinite density at a single point, as our standard model suggests, this theory proposes a different vision, one where a collapsing star or region of matter in another universe reaches a critical point and then rebounds, not with destruction, but with creation. The inside of that black hole becomes something else entirely, a newborn cosmos, sealed from its parent but growing, stretching, evolving. That child could be us. Our universe, with all its stars, galaxies, dark matter, and light, could be the interior of a vast black hole existing in another universe we'll never see. And perhaps every black hole in our universe might be doing the same, spawning new baby universes with their own laws of physics, their own galaxies, their own mysterious anomalies. It's a theory that turns death into birth and finality into origin. And perhaps that's why things like MAMZ14 feel so strange. Because if this theory is right, the structure of our universe, the way galaxies form, the spin they carry, the elements they forge, might carry subtle fingerprints from the black hole that birthed it. A twist in the fabric of reality inherited from a deeper, older world. Even more intriguing is the concept of torsion. In certain advanced extensions of Einstein's general relativity, like the Einstein-Cartan theory, space-time isn't just curved, it can twist. This torsion could play a vital role in extreme conditions, possibly preventing singularities from forming at all. Instead of collapsing into infinite density, matter might reach a limit, bounce, and give rise to something new. A black hole doesn't end in a dead point. It transforms. It becomes the seed of a new universe, one with its own time, its own rules, its own surprises. And this could be the ultimate answer to the puzzle of MAM-14. Because if our universe is part of a cosmic chain, a long lineage of births and deaths, bounces and expansions, then maybe galaxies like MAMS-14 are early hints of this legacy. Maybe the reason they appear so bright, so mature, so chemically advanced, is because the universe wasn't starting from nothing. Maybe, just maybe, it was starting from memory, from something passed down, inherited, and that would explain a lot. Not just the presence of nitrogen or the absence of black holes or the strange galactic spin patterns. It might explain why this universe, against all odds, seemed so finely tuned for life, for structure, for awe. Maybe we're standing in a universe designed by its own cosmic ancestry. The deeper we look, the more the universe seems to whisper that we've misunderstood it all along. Galaxies like MAMZ14 weren't supposed to exist this early, this bright, this complex. Yet they do. They're not rare jewels, but scattered fragments of a cosmic truth we've yet to grasp. Our models told us the early universe would be dark, quiet, and slow. Stars forming gently over time, galaxies growing gradually. But the James Webb Space Telescope is showing us something different, something loud, something fast. The early universe wasn't waiting. It was alive, exploding with stars, brimming with heavy elements, forming galaxies with no need for the black holes we once believed were essential. And just when we thought the mystery stopped at star formation, another question rose from the depths. Why are so many galaxies spinning the same way? Why does the cosmos seem to favor a direction? In a truly random universe, it shouldn't. Unless we're part of something much bigger, a structure we can't yet see, a force we don't yet understand. This brings us back to a staggering idea. What if the Big Bang wasn't the beginning, but a transition? A bounce from inside a black hole? What if our universe is the interior of a black hole formed in another older universe? A place where space twisted instead of collapsing, where time stretched instead of ending. If this is true, every black hole might be a doorway. Every dying star, the seed of a new cosmos. Perhaps the very laws of our universe, its structure, its symmetry, even the strange preference in galaxy spins, are echoes of a deeper origin. And if galaxies like MAMZ14 are already hinting at that hidden complexity, what else is waiting to be discovered? The truth is, we are only at the beginning. The James Webb Telescope is just opening the curtain. Soon, the Nancy Grace Roman Telescope will join the search, scanning vast areas of sky and revealing even more ancient galaxies. We may find dozens, hundreds, thousands of MAMZ14s, each one a puzzle piece from a time before time, each one a whisper from the edge of forever. Each one a whisper from the edge of forever. This is what makes space exploration so powerful. It's not just about distance, it's about reflection. Every discovery out there forces us to rethink what's in here, our place, our story, our beginning. The farther we look, the closer we come to the truth. And the universe, it's only just begun to speak.